Good afternoon, everyone. Can I get your attention, please? Today, we're going to talk about something that I'm really enjoying these days, which is building sustainable softwares using Java application. But before we start in, let me introduce myself. My name is Aicha Laafia. I am a Java software engineer at Havana Group, currently working with a client that's called CFDP, which is a legal insurance company operating in France, Luxembourg, and Belgium. Besides my work, I'm passionate about Java ecosystem, green programming, and sustainability, along with advocating for women in tech. And that's why I'm a Women Tech Makers and Girls Code Ambassador. And because I love sharing, I'm also a member of the Moroccan Association for Computer Science. And recently, I became a JetBrains contributor. Did I mention that I'm Moroccan, living right now in France? And beside all the tech industry, I'm a foodie lover and a Formula One fan. And now you might want to ask yourself is, why you are attending this talk? Why am I giving this talk? Well, my question is for you. Have you ever calculated or just think about energy that your code use? Raise your hand. Oh, that's cool, because most of us just think of software that are something intangible, some just bits and bytes running on the background. But what we don't know is that every inefficient line has a real impact on the planet. For example, did you know that our tech industry contributes to 7% or consumes 7% of the global electricity? Data centers alone consumes almost 2%. That's more than some entire country's energy consumption. And I will not go through the blockchain too, because that's too much. And if you are thinking only about electricity, here is some really scary, not fun facts. Our tech industry contributes to 4% of the global greenhouse gas emissions. That's more than the entire airline industry gas emissions. And if you think that's not related to some daily lives, and if you like watching Netflix, Apple TV, or any streaming, if you only watch your favorite show for 1 hour, you're producing between 55 grams to 100 grams of CO2. And since we are all using emails daily, if we write only 20 emails for 1 day per year, it's equivalent to driving 1,000 kilometers. Imagine only this and this effect. What about every inefficient line we code? How much energy does it consume, and how much CO2 does it contribute to? And this is where we'll introduce green programming. So when you hear green programming, what comes in your mind? What's the word that comes in your mind? Speak. OK, that's good. Efficiency. Another word? Well, efficiency is right, because green programming involves developing software with the focus on energy efficiency and sustainability. That means writing code that uses less power, operating our apps to run more efficiently, and always considering the environmental impact of our software developments. As a Java developer, how we can fix that? How we can reduce these impacts? Well, we have some strategies that we can do for greener Java development, starting with, of course, the most impacted area, which is the JVM, since it's deal with all the hard work, the dirty work of operation, and so on. And you can tell from the first step we're going to start with is, of course, the garbage collection, because garbage collection is not about just memory management, but it directly impacts the CPU load, latency, and energy consumption. And this is why the first step we're going to start with is choosing the right garbage collection. How to do so? Well, it depends on use case. And if you don't know what to start with, we have the default choice, which is the G1 GC. And if you are already using Java 21, you don't need anything. It's already there. If you want something more fancier, we have ZGC, which is a low latency, good for real-time application. And if you want something more advanced and fancier, my favorite one, which is Shenandoah, because it doesn't care about your memory size, whatever it's 2 gigabytes or 2 gigabytes. It's always super concurrent, giving you the best low POSIX ever. And if you're working with batches, you don't care about how much longer your POSIX are. There is Parallel GC. It's so good for high throughput. And if you want only tests, I repeat, only tests, benchmarking not in the production, use epsilon. If you use this on the production, you will end up like this guy here. So since now we like sometimes we choose the good, the better garbage collection, but we still get our application a little bit slow, maybe some unexpected garbage collection. This is where we'll introduce tuning garbage collection. We have this simple example here. We'll try to create 10 million transactions. Each transaction has like unique ID with a random amount. Imagine the garbage collection right now has to deal with cleaning up 10 million objects. As a result, we have execution time is over 20 seconds. That's too slow. Maybe it's because of the garbage collection and how we can really detect if it's the issue on the garbage collection or we're just like making some assumption. The good thing for us as a Java developer, there is already a built-in GZ logs that we can use simply by running this command. Like Java, we execute our Java class with the -xmx logs GC. This is where we tell our Java JVM to give us all the logs on all the garbage collection that we are running through the execution time. Also, there is the -xmx2g and the -xms2g. This is where we try to fix the memory to 2 GB to prevent dynamic expansion. And you will get logs like this. We don't have time to get through all that. This is why I try to recap it for you. And we get the G1, POSIX time, there is 300, there is 700, and the average is 200. And this is why we can tell, yes, the garbage collection are slowing us down. But how to fix that? This is what's all about tuning garbage collection. Instead of relying on the JVM setting default, we adjust that. For example, you can use the -xmx GC POSIX millis to 50 to reduce the target time. POSIX time, we have the -xmx G1 heap region size to 8M. To optimize memory region size, we have the -xmx initiating heap occupation %. That's to trigger all the old one. And we have the -xmx G1 mixed GC count target to 8. Still us to use maybe only 8 garbage collection instead of having unnecessary ones. And as a result, we get this. Our execution time dropped from over 20 seconds to 12.7 seconds. That means we have lower execution time. We got to fewer old GC promotions since we limit numbers and more sustainable greener usage. But what if the garbage collection isn't the culprit? Maybe it's the execution method itself. And this is where we call just-in-time compilation. What does it do? First, it detects your most frequently used method and compile it directly at the runtime. How to do so? Well, we have some techniques. For example, we have the inlining. This is where instead of just every time we call the method, so we will waste time on the calls, go through in and out the method. We just compile the code directly each time. We have the escape analyze, where just-in-time allocation or just-in-time try to prevent any unnecessary heap allocation. And we have the loop enrolling, because sometimes you don't have to get through all the iteration on a loop to do the work. So just-in-time do the work for us and only get us through the right amount of iteration. I'll try to show you an example of the escape analyze. But sometimes we need to help just-in-time compilation do its work. For example, we have the transaction record with the ID, string reference, and double amount. When we run our code, we get over 5.6 seconds. How we can fix that and help just-in-time compilation do its work? Because right now we are paying a tax performance by only making the garbage collection clean 1 million objects. How to do so? Simple thing. For example, go from here, transaction with the int ID. We remove the string reference. We keep only the int ID and the double amount. And right now we are dealing only with primitives. And we let the just-in-time compilation, instead of allocating 1 million objects on the heap, it's they allocated directly on the stack, because we're dealing with primitives. And that means we have no GC pressure, the garbage collection don't have to do all the works, and we get less execution time. Also, I did one thing I need to mention. We have I used here the virtual treats, and I replaced by structured concurrency because yes, virtual treats are very cool feature, but they have some waiting, like long waiting method for the treats. Instead, if we're going only for methods that are using, for example, like calculation, like here, or doing some simple task in input-output, we can just use simple treats, traditional one, or the structured concurrency too to avoid the waiting time. Because not everything is new can be like the good for use case. And as a result, we got like 3 times faster from 5.6 millisecond to like 1.7 seconds, sorry. This is mean like we have less memory pressure, lower CPU usage, and more sustainable and green Java. And now that we have seen how we can help just-in-time compilation do its work and how we can optimize some garbage collection, it's time to see like the real another aspect of sustainable Java like practice, which is second strategy is analyzing the resource usage. You have to know that even the fastest code doesn't mean that it will be the greatest. Maybe it could drain any unnecessary any unnecessary resource use, and this is why we need to analyze where our resources are needed, and so on. How to do so? Well, first we need monitor and profiling our Java application. We need to check if there is a CPU like bottlenecks, if there is a memory leaks we can fix, or there is some GC pressure that we don't know about this. How to do so? Well, we can use the gcontroller, we have Visual VM, we have like Java Mission Controller, or any tool you feel comfortable with. Also, we have to know that operations do not do the same thing, do not use the same energy amount. And this is why we need to identify the exact operation that drain our resources. And how to do so? We have the GMH, Java Microbranch harness to analyze, for example, just-in-time optimization to check where we can help or we can remove or modify our code to help just-in-time do the work itself. And of course, we can step up in our analyze. We have the gprofiler, ukit. If you use Epsilon, well, the good thing there is Epsilon, Eclipse, MIT, sorry, if you are using Eclipse, and so on. Also, one aspect that we don't care that much about because we only talk about the CPU in memory, but what about energy consumption? Especially since our tech industry contributes to 7% of the global greenhouse of the global electricity. How to do so? Well, we can use, for example, if you are having a macOS operation, we have the macOS power metrics that can give us some real-world energy usage measurement. And that's what we're going to see in our next slide. It's really simple. You only need to run this command here with using some pseudo parametrics. We sample CPU power for 1 second because here it's for the millisecond. This is why we put 1,000. And we tell it to only for 10 samples that can really calculate. And how to convert the CPU power from what to the energy. It's only simplifying. Use this formula to calculate the time per hour for the power usage that you will get on the result. For example, I already tried to measure it before. I have my greener code that I already optimized. I run the command and I got a CPU power consumption to 1.53 watts. And when I run the old, not cleaner, heavy eater energy, I got almost 3.76 watts. Imagine that our an inefficient, non-efficient code has a power consumption of over 146 increase than the greener one. To remember, please optimize usage to help for more greener, sustainable Java application. And since we already talked about how we already measured the energy that our platforms or application consume, it's time to take action. It's time to reduce that. How? Simply, always go for efficient memory management, then minimize your input-output operation, and of course, you need to reduce the wait, idle time, and the power usage. How to do so? Well, first, let's talk about memory because, excessive memory usage leads to unnecessary CPU cycle and the wasting energy. That means that, for example, we want to randomly access to a list, and we randomly say, let's go check with linked list. but we cannot really avoid like the pointer overhead. Instead, we can just use the simplest array list that will avoid us any unnecessary time. Also, if you want to add a character to your string, but you said let's go with the traditional plus operation, but did you know that the string are object immutable? So each time you add a character to it, you are creating a new object. Imagine you want to add 1,000,000 character. And right now, the garbage collection are dealing with cleaning the 1,000,000 objects. How to do so? You can switch the string builder that we are now only dealing with one object, whatever you are going to add 10 millions, 100 millions of characters, garbage collection are only cleaning one. Also, like for a more safe treat, we can use the currents. Like if you are dealing with maps, you don't have to wait time for the treat. We have the current hash map. It's so good, and also like saving us for idle time. And now, maybe because we have to deal with something else, which is like heavy input-output operation that can drain power too. We can simply use something like buffered input-output operation and asynchronous input-output operation to reduce the blocking and the waiting time, because the traditional streams sometimes block, and or we have to wait for the operation to, instead of just letting them like go on execute in the background. And this is where we can use something like completable feature. It helps execution multiple input-output operation at the same time in parallel. But sometimes even like when our application are not working, it's still like wasting some cycle circle. And this is where we talk about the idle time. How to reduce that? It's only about implementing techniques like thread pooling to manage resource more efficiently. Here we will talk about the fork join pool to distribute work across like available CPU cores more efficiently, and of course always reducing this wasted cycle. We have also structured concurrency. I love this feature because it prevents unnecessary access thread waiting, keeping the execution time more faster and streamlined. But sometimes we do all this and we still have a problem, not that much greener, because the core of green Java development is our fine last GVM optimization techniques or strategy, which is choosing the right algorithms. Because our algorithms define the way we treat our information, the way we deal with our programs. We can call it that's the core of our programs. And this is why choosing the right garbage collection, the right algorithms with the right garbage collection can guarantee for us that we will have the greenest application ever. But we deal with one thing, because as we said before, the fastest algorithm does not mean the greenest. We need to get through if it's not only like less execution time, but less energy used too. And we need always to balance performance with sustainability. For example, let's say we want to sort a massive list, and our team said, okay, let's go with the quick sort because it's quick. Well, we can say the issue is that quick sort performs unnecessary swaps in comparison. Let's imagine we have a nearly sorted list, and quick sort will go through all the lists for all the comparison and sort even the already sorted elements. What to do so? Let's introduce the time sort. What I really love about this algorithm, it can detect easily the unsorted elements, sort that, and that's it, without going through all the list. And as a result, fewer computational, fewer power consumption, and much greener algorithms. And that small switch can give us a really smooth, greener operator. So be like Carlos Sainz if you are a Formula One fan. You can know the reference. And now let's go beyond the Java code. Did you know that if you prefer cloud-based solution, you contribute to green programming? Because cloud providers often offer for us like the greenest friendly energy resources in data centers that offer scalable resource that can be managed instead of the traditional one. When you are faced with the default setting, the default CPU, and the energy consumption that we cannot modify, and so on. And that can lead, when we use the cloud-based solution, to a significant cost and energy saving. And that's something you can tell to your stakeholders and boss, because greener, sustainable application can save you a lot of money on the long term. And we talk about cloud-based solution, of course, we're going to talk about Kubernetes. And what's a better way to manage our resources than the autoscaler, like especially the horizontal pod autoscaler. What I really love about it, because sometimes we have our workload is so heavy, we have to adjust our resource monitoring. But what if we forgot about to lower it down and we got to waste much energy? And this is where the HPA say, hey, you have too much resources, I'm going to adjust, I'm going to increase the hype. But when the work are done, they are always lowering, scaling down our resources, making us always balancing between resource usage and our demands. It also giving us more cost efficiency. And this flexibility helping us really ensure that we have greener, sustainable application that's running on the cloud. There's also what we call the VPA, which is a vertical pod autoscaler. It's the same thing, but for the nodes. They check the node on the pod. They check if we are having that much nodes to do the work, or less, to prevent provisioning or wasting node resources too. So to recap, when we combine between Java and Kubernetes, we hit the sweet spot of efficiency. Because containerizing Java application, we got flexibility, and Kubernetes take care of all the resource allocation, whatever it is, automating deployment, scaling, or the managing of containers. But one more thing or tips to say, please, if you can only if you have only to use 4 containers, build 4 containers. There is no need to create tens of containers. We're only using 5 or 6. So remember, please reduce, recycle, and reuse your containers. If you want to help the environment, not only recycle your actual garbage, but the virtual one too. And right now, let's advance on more monitoring. We did our effort to optimize, but how we can check if we did a good thing. This is where we'll introduce tools to track energy consumption and carbon emission of our application. In my favorite one, there is the Green Software Foundation's Carbon Aware SDK, a tool that can help you see how much your application while on running, how much carbon they are producing. There is also Dynatrace. I love Dynatrace because they provide some CPU, energy, and even the carbon emissions calculation. All this with some AI-powered analytics and dashboard too. I love their dashboard. Also, something we are familiar with, which is Promothoughts and Grafana, that can help us to see some really CPU and real-time analytics and visualizing data too. And now it's time to see some real-world example of startups and companies that implemented green programming. Starting with the green tech software solution. They based their company on developing energy-efficient software for environmental monitoring. They always make sure they're having the best green programming practice used in their daily life. For example, optimizing algorithms with minimal computational complexity and so on. And as an impact, they achieved 30% of reduction in energy consumption, and of course, they significantly reduced their footprint. To see that in number, here is the win. Green tech software solutions save up much money to power 200 houses for a year. And that's the win we're talking about. There's also Monzo, which is an online bank that not only helps their customer to simplify and digitalize all the administration and banking operation, but it also involves their customer in sustainability in movements. And I'm talking about 500,000 customers. All this will making sure they have the best greenest practice by optimizing Java microservices, using Kubernetes for resource management, and always preferring cloud-based solutions. So all I can say is get inspired by them. See how much effort they reduce. Also, I forgot to mention because they had 35% of energy reduction, and that's something we need to salute for, or congrats them for that. And as I said, it's time to get inspired by them. If they can do this, why not do the same? Because what I have to alert you is that green software, to start with, is something not that simple, but not impossible. Because the real dilemma we have is how to balance between performance and sustainability. And now, it's time for action. Remember, start small. Baby steps are better than zero steps. Today we will just say, today I'm going to check how much energy our application are using. Tomorrow I'm going to change one line of code, use array list instead of linked list. Next week I'm going for a cloud-based solution. But what about 1 year you'll find yourself reduce many energy and the planet will thank you. Also, remember, educate and advocate. Not many people know the real impact of any inefficient code they wrote. And this is why we need to tell our entourage that codes are not written bytes and that we contribute to the pollution, the digital pollution too. We contribute to CO2, and we need to reduce that. And finally, join the movement. Look for green software application. Look for events that talk about sustainability. And if you are using CNCF products, there is a CNCF group that's called the Green Tag Review. You can check what they are doing, and they are really doing some green job. Also, there are some green, I think it's called Green Cube, which is, if you want more advanced autoscaler for Kubernetes and containerization, you can check that too. And here is some results. If every Java developer right now optimizes their code, we can reduce the global energy consumption that's equivalent to removing 2.7 to 3.8 million cars from the road. And if you think I'm exaggerating, you are welcome. I have the calculation. And it's time to see Bedanki. Thank you all. And please, before going, maybe you can provide me some feedback here. And if you want to read some articles, I already have more about green programming in Java, green cloud, and some article related to the greenest cloud provider too. If you have any question, please feel free. And also, I have some GBrain swagger you can take here. I already put it here. Feel free to get whatever you want. In Bedanki.